Okay, this is Bridge to Algebra 1 Math Academy Summer Packet, and we're on page 29 working with spheres. And there's two parts to this page. The first part is finding volume, and the other one is the surface area. Volume is how much is the capacity of a three-dimensional figure, what it can hold, such as a tanker. You know, how many gallons of oil can a tanker hold? In this case, though, we're not doing tankers, we're doing spheres. Examples would be how much air in a basketball, soccer ball, things like that. So here we go, volume of a sphere. Let's take an example down at the bottom. And we're going to take this, we're going to find the volume, and we're also going to find the surface area. So here we go. Let's start with volume. Volume equals 4/3 times, we're using 3.14 for pi, times 3.2 to the third power. And so when we multiply that out using a calculator, I recommend you go to Google and type in volume of a sphere, and it'll give you a calculator, and it'll show you a sphere. And let's do this. Let's do an example right now. We're in Google, volume of a sphere, and right here we're going to enter 3.2. 3.2. Get rid of this. Now we're going to hit enter. And what that does, it actually works it all out for us. So here's a picture. I'm going to copy this. We're going to go back to my where we were. Here we go. And we're going to paste that in. There you go. We're going to zoom in. Let's crop this down to right there. Blow it up. Now we can write on it. So what we have is, here's your formula, right? Whoops. Here's your formula right here, 4/3 pi r cubed. And when you multiply it out, you get approximately 137.25828. So when you go to Google, type in volume of a sphere, you'll see this up here in the address bar. It'll just give you a little picture of a sphere, and you just type in your radius. Make it easy. So that's volume of a sphere. Yep, there goes my dog barking. So approximately 137.26 miles. Volume is always in cubic miles. So there we go. So an example of what would be 3.2 miles. Maybe it's a little asteroid. That's in a spherical shape. Now we're going to find surface area. Again, formula for surface area is 4 pi r squared. So we're going to do A equals 4 times 3.14 times 3.2. We use the same radius, 3.2 miles squared. Let's go back to Google. And up here we're going to, instead of volume, we're going to do surface area. So there we have it, surface area. We're going to enter a radius of 3.2. And there it is. And we'll go ahead and shrink it down. We'll go back to our, and we'll paste that in right there. And there we have if we look down here, the formula, and they plug it in, 4 pi r squared, that's 4 times pi times 3.2 squared. If you follow your order of operations rules, you have to do this squaring first. Then you would have to take 4 times pi times whatever 3.2 squared is, and you get approximately 128.68. And you'll notice how, let me go back and fix this over here. This is an approximation. Because this is surface area, you're actually covering the surface. This is going to be, instead of miles cubed, it's going to be miles squared. Area is coverage. Coverage always is square units. Volume is capacity, and capacity is always cubic units. So there's how you do volume of a sphere and surface area of a sphere. And you got some examples up there. And pretty easy. Use Google. If you don't have a calculator, if you do have a calculator, obviously you can do that, but Google makes it easy. You can just plug it in, write down your formula, show your work in terms of writing everything down. And that is those two parts. Let's go to day 10, bell work. I want to go over a couple things that we ran into during summer math camp, boot camp. Had several people come in, quite a few actually, and work on their summer packets. A few got it done. But what we're going to do is talk about box plots. We have a box plot here. And it says list the following integers from least to greatest. You should be able to do that. Then we have a box plot where you have to answer these questions right here. This goes with this. Okay, so this is one problem right here. Here, we'll just do this. So that's the problem. The first problem is separate from the second problem. So sometimes it looks like it blends in, but it doesn't. So what we have here is, keep in mind, just as a review about box plots, I'm going to go from here. And we're going to divide this up. So this is our minimum right here. Do we know what that is? It's hard to tell. It's a little bit more than 2. Here's our max, just shy of 9. 5.5 is your median right here. So let's not forget this. This is the whole point of going through this. Here's your median. And this may be a little bit difficult to comprehend, but you got to keep in mind that the box plot only shows you how far spread out the data is. For example, this is quartile 1, this is your median, or it's also known as Q2. This is Q3, and this is and so you got your min, your max. Is 5-number summary. You got your min, your max, and your median, quartile 1, quartile 3. So in this section right here is 25% of all the data. In this section here is 25% of all the data values. In here is still 25%. It's just really, when you think about it, they're all tight. They're all between 5.5 and somewhere a little bit more than 6. Over here, you got 25% of your data values. It's just that they're spread out. They're anywhere from 6 to 9 approximately. So when we look at this right here, this is from 2 to 4 is 25% of your data. From 4 to about 5.5 is 25%. Then you have a whole bunch of data values right in this area here, but it's 1/4 of the entire set of data is in that little area. They're not spread out. They're bunched together. And over here it's spread out even more. Now, it might be that there's an outlier out here that causes this to spread out, but nevertheless, the data is still 25% out there. 25% here, 25% here, 25% here, 25% here. So when we think about that, the median separates the upper half and the lower half. The upper half is 50%, the lower half is 50%. Then you've got your inner quartile. Your inner quartile is from your Q1 to Q3. So that's your IQR. It represents 50% of the data. So that's something to think about when you're answering the questions on problem 2. It says 88 people were interviewed. How many people watch TV between 4 and 5.5? So they want to know how many people there are in this section here. And the key is knowing that this section represents 25% of all the people who were interviewed. So that's just a little bit of a review of a box plot, box and whiskers, and how the data is spread out and what it represents. So again, we covered day 9, page 29, and page 30, bell work.